Hey guys, welcome back to our review. Today we're reviewing some trig stuff. So we already reviewed the unit circle. Let me be honest about what you really need to know in calculus. This week, the stuff that I'm reviewing is really the stuff that you absolutely positively have to know and know it well in order to succeed in this class. You know how the unit circle is. If you don't know the unit circle, you pretty much struggled all through pre-calc. It'd be like not knowing what -1 + 3 is in Algebra 1 and thinking you're going to do well. You're not. You got to learn those basics. The unit circle is that for pre-calc, and these few things that we've done today and this week, they're the things that you need to know well in order to survive in calculus. Now, your pre-calc knowledge, all I really need you to know from pre-calc that I won't reteach you anyway, I need you to know your unit circle and how to solve these trig equations. Okay, so here we go. All right, so we already did this in my last slide, or my last lesson. And by the way, it wasn't nearly as much fun as I thought it was going to be to teach that lesson because I don't have any faces to look at. I don't get those oohs and ahs in the expressions. It wasn't as much fun. But anyway, so to summarize, we did the unit circle in radians. And hopefully you remembered the 30-degree angle right here has the two numbers, the square root of 3 over 2 and 1/2. That's really all I need you to write at the top of your paper. From now on, anytime you have a trig problem, I want you to be able to get away with just that one number, the 30-degree increment, which you know is pi over 6, because that one should remind you of all the others. If we go up pi over 6, down pi over 6, these guys are the same. And up pi over 6 and down pi over 6. All of those are the same. Okay? And then you work with the signs later. Then if you go up 2 pi over 6, switch them. But you don't have to write those all in. You should really only have to write in this guy right here. Okay? And then if you end up getting an answer over here at 5 pi over 6, you know it's negative and then positive, so negative, positive. Okay? Cosine, sine, cosine, sine. So I'd really like you to try to get used to just visualizing quadrant 1. If you draw the rest of the tick marks in, because it helps you count, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, I get that. That's okay. Draw it in if you have to. But try to get by with just visualizing this one quadrant, and better yet, this one set of numbers, because all the other ones are just reversed. Assuming you remember for the 45-degree angles that everything's the square root of 2 over 2. All right, moving on. Okay, so we're going to now solve equations involving trig. Don't let these scare you. These are pretty common in calculus, but they're no big deal. Treat the sine or the cosine like it's an x. If this was just an x, and I had something like 4x plus 7 equals 2x, what would you do? If you're unsure, change the sines and the cosines to x's. I know I made the 7 look a little easier, but whatever, same thing. You would basically get the like terms together by doing the opposite. Well, we're going to do the same thing right now with the sines, okay? So get the sines together, subtract 4 sine theta on both sides. Okay? And just like over here, we keep the x. That's negative 2x. The same thing's going to happen on this side. Bring down the square root of 3. 2 minus 4 is negative 2 sine theta. Okay? Just like over here, the next thing we would have done is divide by negative 2. We're going to divide by negative 2 here as well. So we get sine theta equals negative square root of 3 over 2. Okay? Now we have to go a little bit further. We have to find where on this unit circle does sine equal a negative square root of 3 over 2. So remember, in the first quadrant, this is cosine is square root of 3 over 2. So that tells us already that we're going to be in a pi over 6 spot, like one of these guys. But sine is negative. Remember, it goes over cosine and up sine. So sine is negative down here in these two. Okay? So it's going to be this spot and this spot. Okay? Hopefully you can visualize that, because this guy was a square root of 3 over 2 and 1/2. So this guy is the reverse. Okay? And sine is negative because I go over and down. So this is where my sine is negative. And same with over here. So we have this, wait a minute, what did I say? Okay, so we have this guy and this guy. Now we have to figure out what those are called, so I count by fractions. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Could have started there. 7, 6, 8, 6, which is 4 pi over 3. Get rid of this. Okay, so we're at 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, which is 5 pi over 3. Now, if you were good at memorizing, then you just know what it was. But I find that memorizing doesn't stick for very long. If you didn't remember the unit circle over the summer, then you probably aren't so great at memorizing it either. So learn to count by fractions around that unit circle. Okay? We didn't have to name all of the rest of the infinite number of answers because this said to only go between 0 and 2 pi. Okay? So watch that again if you need to. And try to practice doing these problems without having to draw an entire unit circle if at all possible. Okay, I'm going to get rid of that and show an easier problem. Maybe I should have started with the easier one. On number 2, get the cosine by itself, so add 1 to both sides. You get cosine theta equals 1. Now solve for theta. When does cosine equal positive 1? Remember, this is 1, 0, negative 1, 0, 0, 1, 0, negative 1. So when is the cosine equal to 1? It's C and then S, so that's this guy right here. So it's either 0 degrees or 2 pi, depending on how we name it. But if you look back at the instructions, it says that 0 is included, but 2 pi is not, so my answer would just be 0. All right, a trickier one than that. Let's see what else we got. All right, this one can be a stumper for people because they don't know what to do with this. And usually if you guys were here in front of me, I would ask you to try it on whiteboards so I could make a fool of all of you because it brings me joy. So I challenge you to pause and write on a piece of paper what you think you would do for this problem. And basically I only need the first step. If you tell me the first step correctly, I'll be so proud. So hit pause. Okay, well, let's see what you did. If you are unsure, the next wise thing to do is change the signs to x's. Okay? Oops, hold on, lost it. Okay, I'm going to change those signs into x's. So if you rewrite it as 2x squared minus x equals 1, would that jog your memory? Hopefully it does. It's a quadratic equation. We reviewed it earlier this week. If it's an x squared or higher, set it equal to 0. That's all you should have done. That's it. You have to set it equal to 0, and you have to factor. So subtract the 1. Okay? Factor. Two numbers that multiply to 2x squared would be 2x times x. Two numbers that multiply to a 1, that's convenient. 1 times 1. Now make your inners and outers add up to this negative 1. So I'll need a negative 2 and a positive 1. So that's what that will factor into. And then you set each factor equal to 0. And we get x equals negative 1/2 for this one and x equals 1 for this one. All right, so now we're going to do it with signs. You could just go back and plug the signs in there, but you want to get used to working with them. So I'm going to treat that sign just like we treated that x. So for starters, subtract the 1, set it equal to 0. 2 sine squared minus sine minus 1 equals 0. Factor 2 times sine theta times sine theta. Okay. Two numbers that multiply to a 1. Everything else is the same here. 1 and 1. My inners and outers have to make negative 1. So this is negative, this is positive. And now set each factor equal to 0. Okay, if 2 sine theta plus 1 equals 0, we'll get some solutions. And if sine theta minus 1 equals 0, we'll get some solutions. Okay, so the second one's easier. Sine theta equals 1. Go to your unit circle and find out when sine equals 1. So cosine is left and right, sine is up. So sine equals 1 right here. 90 degrees, but we're in radians, so it's pi over 2. It's radians for the whole year, never degrees. I only did degrees just so you got a little bit warmed up. All right, this one, oops, I forgot the theta on this one. Okay, get the sine theta by itself. So we're going to first subtract 1 and then divide by 2. And then look on your unit circle. When does sine equal negative 1/2? Well, the first spot is square root of 3 over 2 and then 1/2. So sine is 1/2, so that's right. It's just one spot away. So we're going to go one of these four, right? So which one is sine negative? We go over cosine and down sine, so it's this one and this one. Now, again, trying to do it without cheating and looking at a unit circle that's all completed. What are those guys? Counting by 6. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. So theta equals 7 pi over 6. And if this is 2 pi, so that's 12 over 6, so this is 11 pi over 6. But we could have gone 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6. 11 pi over 6. So all of these answers would be given as just one answer. Hope you're hanging in there. I wish I could see your faces. Okay, this last one is also a stumper. People are like, I don't know. What do I do? What do I do? Okay, well, try doing what we did on the other one. Make the cosine an x, maybe. Make the sine a y or something. So if this was x minus 2xy equals 0, would you know what to do? Well, they both have an x in common, so you factor out the x. Okay? So that's what we're going to do. For this problem, we're going to factor out what they have in common, which is the cosine. You can't divide by cosine theta on all sides, and the reason you can't divide by it seems like it'll work, but if you do that, you actually lose some of the answers, and that's because when you divide by a variable, this is wrong, don't do this. If you divide by a variable, okay, if that variable represents 0, you're losing one of the answers. And cosine theta does sometimes equal 0. So don't do that. All right, the right way to do this problem so that you get all of the answers and don't lose some of them is to factor out the cosine instead of dividing by it. Okay, so we're going to factor out the cosine theta. Okay, now think the opposite of distributing. Cosine theta times what will give me back cosine theta? 1. Cosine theta times what will give me back this term? Negative 2 sine theta. Now it's factored. So set each factor equal to 0. Cosine theta equals 0 gives some answers. And 1 minus 2 sine theta equals 0 gives me more answers. Okay, if cosine theta equals 0, cosine equaling 0, that's here and here. So that's pi over 2 and 3 pi over 2. And this one, sine theta equals, subtract the 1, divide by negative 2. So we're looking for where sine is a positive 1/2. Positive 1/2 is going to be here and here. Pi over 6 and 5 pi over 6. Okay? This is maybe not your easiest review, but it is review. I hope you're doing okay. Let me know if you're not, if you're struggling. Okay? And I'll see you guys soon. Here's your assignment. Good luck. Try to do it without looking at a unit circle. Try to do it in your head, and then when you fail, look at the unit circle, but then try again to do the next one without looking at that unit circle. Good luck, guys.